to start geometric sequences. Tomorrow will be geometric series. Friday will be applications of geometric sequences and series. And we're going to take a formative on Friday. Next week, Monday, I don't know. I think we're supposed to have class, but I don't know how long Battle Royale is going to go. Because Monday morning is Battle Royale. We have to start. I have no idea. I don't know. Because sometimes it goes long, sometimes it goes short, and then it's one of those things where I don't know. So Monday might be a learning day. Monday might not be a learning day.
So what if it doesn't be a class hours for like sit here and
Probably.
okay. Perfect.
Wednesday then will be infinite geometric sequences and series. We really only need one class for that. Thursday will be a review. Friday the 17th will be your sequences and series test. Okay? All right? So that is the plan. All right. So we were talking about an arithmetic sequence up to this point. What did we do to get the next term in an arithmetic sequence? We added, right? We added something, okay? Sometimes we added a positive number in the sequence group. Sometimes we added a negative number in the sequence or the term, the value of the term like that. Okay? Okay? Geometric now, a geometric sequence is a sequence that has a constant ratio between the terms. An arithmetic sequence, I wanted to say last week, but it was the last couple of days, had a constant difference between the terms. So we add ratio now. The basic idea is we are going to be multiplying. To get the next term. Now, how can you tell the difference? Well, in an arithmetic sequence, we always look to see if we subtracted one term minus the other, and that always gave us that constant difference. Here now, you're going to take a term and you're going to divide it by the term right before it. And that's that ratio that you get. Any term divided by the term before it gives you that constant ratio R. We're going to call that ratio R. Okay? So what this looks like, come on now. There we go. Now we're going to erase. There we go. Okay? So what this looks like is, oh, come on. Jumping all over today. Okay? So here, I'm multiplying by 2. All the way through. But if I didn't see that, I could take any term and divide it by the term right before it. So 4 divided by 2 is 2. 8 divided by 4 is, oops, I broke 2. 8 divided by 4. Got it in my brain like a pretzel. divided by 4 is 2. 16 divided by 8. 2. 32 divided by 16. 2. All those are equal. If you have two consecutive terms, and you know it's geometric, then you know what the constant ratios are. In the second one, what's my R value? One half. Okay? I take any term and divide it by the term right before it. 100 divided by 200 is 1 half. 50 divided by 100 is 1 half. I almost put 120. 25 divided by 50 is 1 half. 12.5 divided by 25 is 1 half. What's my constant R down here at the bottom one? Negative 2. Okay? So we can have negative values. Okay? R can be anything except for two values. Well, actually, I should say it can be anything. Okay? But the ones that we don't like are 0. Okay? We don't like 0, because that would just be the first term, and then zeros every term after that. And we don't like 1, in our value of 1, because then it's just going to be whatever that first term is, that term. Okay? So those two. This is the rule for a geometric sequence. Now, if you'll notice, the very first thing that happened is arithmetic sequences in series had A sub n and A sub 1. Geometric series and sequences have G for their letter of choice. Okay? So we have G sub n is equal to G sub 1 times R to the n minus 1 power. G sub n is any term in the sequence, or the term that you're looking for in the sequence. G sub 1 is the first term in the sequence. R is that common ratio. N is the number of terms, or the term number that you're specifically looking for. And 1 is 1. Now, two things in terms of geometric sequences. One, your terms have the potential, your individual terms have the potential to get really big really fast. If you're multiplying by like 7, let's say, you start with 1. Your first term is 1. Your second term is 7. Your third term is 49. Your fourth term is 343. No. Yes, 343. Next term is over 2,000. So within 5 terms, you've gone to over 2,000. So the potential is there to get terms really big, really fast. Conversely to that, the potential is there for your terms to get really small I say this. We are not going to round anything. We're going to leave our answers in fraction form. Fractions are your friends. Okay? Because it's cleaner, it's nicer, it's neater. Okay? So we're going to leave answers in terms of fractions until we get to application type problems. Then it doesn't make sense that if we're talking about minutes, let's say, if there's a minutes problem on the formula, right? It doesn't make sense to say, well, it's 776 over 19 minutes. Okay? So if it's just a regular sequence and series, we're going to leave it in fraction form. Let's get into it. Okay? So we want to write the rule for the geometric sequence, and then we want to find the seventh term. Okay? Well, if I'm going to be writing the rule, g sub n is going to equal my first term. So I should identify what my first term is. What is g sub 1 in this particular sequence? 4. Okay. Then I need my r value. Well, what is my r value in this sequence? 2. Those are the only two things that I need to write the rule. It's not like the other. Well, actually, no, we only needed two things to write the rule in the other one. Okay? Right? So you needed d and you needed the first term. Well, we got that. So my rule, g sub n, is equal to 4 times, and I like to put it in parentheses, because that 2, and only that 2, is being taken to the exponent of n minus 1. The 4 is not part of the exponent. It's not part of the base. Only r is being taken to that exponent. Okay? Then it asked us to find the seventh term. So g sub 7 would be 4 times 2 to the 7 minus 1 power. 7 minus 1 is 6. 2 to the 6th power is 64. 4 times 64 is 256. Okay? You want to try one on your own? Go for it. Try the letter B. Find me the rule, find me the seventh term. First term, 2/3. R value. How'd you come up with that? So you did 1/2 divided by 2/3. Keep change flip tells me that's 1/2 times 3/2. Multiplying fractions tells me that's 3/4. Right? Okay. So my rule then would be 2/3 times 3/4 to the n minus 1 power. Yes? Okay. We need to find the seventh term now. And your mean old math teacher said no decimals. So how can I make 3/4 to the 6th power in fraction form? Or how do I keep it in fraction form and still be able to find it? Talk about it. We want this in fraction form. And it's not working. The calculators are failing us. So let's blame the calculators instead of using our brains. How can I make 3/4 to the 6th power still be a fraction? 6/1. Okay, that's not going to help me. It's still in the exponent. How do I make 3/4 to the 6th power be a fraction? What do you got here? Bingo. Okay? Exponent rules coming back to haunt you. Okay? That's 3 to the 6th power over 4 to the 6th power. Three to the 6th power is 729. 4 to the 6th power is 4,096. $4,096 divided by 2 is 2,048. 729 divided by 3 is 243. And that, you may not believe it, but that is much cleaner than 0.11865234. Okay? You got to get to love them. That mindset right there is why this took so long. Because that's not that hard of a problem. But you guys see the fractions and you're like, nope, I'm done. I can't do them. BS. All of you have the ability to do fractions. It's just your mind says, nope, I'm not going to do it. And so you don't do them. They're not that hard. They're easier. Because how did you get this 0.118 number? You did this. You went one more step. Fractions are quicker. Fractions are quicker. Okay? You just choose not to do them. Then you run into issues. Okay? So, same style of problems that we could have. I could give you a list. That was the first style of problem, just like we did in arithmetic. Second style of problem, I can give you a specific term and the R value. Ask you to find the rule. Okay? So in this particular one, so I know I've got my whatchamacallit up there, my rule. I know that negative 16 is the 6th term in that sequence. So I could use my rule to find my rule. 6 minus 1, 5. So then this becomes negative 16 equals g sub 1 times 2 to the 5th. 2 to the 5th, 32. So this is negative 16 is g sub 1 times 32. How would I solve that for g sub 1? Divide both sides by 32. Negative 16 divided by 32. Negative 1/2. So my first term is negative 1/2. Which means then that my rule is negative 1/2 times 2 to the n minus 1. Yeah? You try letter D. That's going to be 12 equals, don't know g sub 1, times r is negative 3 to the 4 minus 1 power. So that's going to be 12 here is equal to g sub 1 times, that's going to be negative 3 to the 3rd power. So that's going to be negative 27. So divide both sides by negative 27. And I get, what do we got? We can divide by 3. So that's 4, negative 4/9. So g sub n is negative 4/9 times negative 3 to the n minus 1 power. My question to you is this: what if I don't put r in parentheses? Those kind of moves, doesn't it? If I would put it in there, and mathematically it would be solved. And then it'd be minus, I'd be subtracting, and then the negative sign would be, you know what I mean? Yeah. So definitely want to put r in parentheses every single time. Yeah, buddy. Okay. Third style of problem, 2 terms. Okay. Same as last one. Arithmetic. We can do the same kind of problems that we did with arithmetics. Okay. So now what you've got to do is same as we did last time. You got to set up a rule for this one. So that would be 48 is equal to some first term times r to the 4 minus 1 power. I don't know my first term. I don't know my r value. So, but I do know that 48 is going to equal g sub 1 times r cubed. Then you're going to repeat that process for this one. So now I got green and blue. Okay? What you're going to do is you're going to solve one of the equations for G sub 1. Helpful hint, solve the one with the smaller exponent for G sub 1. Which one, blue or green, has the smaller exponent? Green does. So I'm going to solve green for G sub 1. Oops. Okay? That should take literally 10 seconds. Probably take you longer to write it than the thought that you actually used to put into dividing by whatever R is, or R with whatever X. Okay? Then, I'm going to take that and I'm going to put it into the other equation. 1536 is equal to, now I have G sub 1 as 48 over R cubed. The right side of this equation, what is it equal to? Left side is 1536. Right side, what is it equal to? 48 R to the 5th. Yep. Okay. 8 R's on top, 3 R's on the bottom. There's 5 more R's on top. So it's 48 R to the 5th. I need to solve that equation for R. Divide both sides by 48. 1,536 divided by 48 is how much? 32. (32) equals R to the 5th. Still need to solve for R. Square root is not enough. 5th root it, because I got to the 5th power, so I'm going to take the 5th root of both sides. What is the 5th root of 32? 2. So my R value is 2. Yep. Makes sense to put R back into that equation right there, the purple one, right? 2 cubed. 2 times 2 times 2. Shouldn't need a calculator for it. You got here? 8. 48 divided by 8. 6. My rule. G sub n is equal to 6 times 2 to the n minus 1 power. Now, if you notice the process that we just did, okay, we got down, so if I'm following the blue all the way down, we got down here and we took the 5th root. Taking an odd root, not a problem. What happens in math when you take an even root? Get out. Positive and negative, which means you get 2 different R values, which means you have to come up with 2 different rules. It's one of those quirks with geometric sequences and series. This is one of those quirk type ones. Okay. So let's set it up and we'll get to the quirk. Oops, I did green first. So 48 here. So is it going to have the smaller exponent? Yeah, because it's the lower number of term, right? Or it's the lower term number. Yeah. So we can just solve this one right away. We can do that next step right away. We can solve this one and say this is really that, right? With me so far? Substitute. Yes. 3, I'm guessing it's 64. What root am I going to take? 6. Even root. So we get plus or minus 2 there for my R value. Which means when I go back here to substitute, if I go with positive 2, then I have 48 over 2 cubed is going to be 48 over 8, which is going to be 6 for my first term. Yes? But if I go with negative 2, then it's 48 over negative 2 cubed, which is 48 over negative 8, which is negative 6 for my first term. So I have to give 2 rules. It's either going to be, if I go with the positive one first, 6 times 2 to the n minus 1, or negative 6 times negative 2 to the n minus 1. Okay. No, the negative doesn't always go with the negative. Meaning that a negative R value doesn't always give you a negative first term. Positive R value doesn't always give you a positive first term. You gotta still do the math. Okay? They should be the same. Okay? They should be the same number. Just you gotta figure out the positivity. Okay? Both of them would be required to be correct in a problem like that. Questions, comments, concerns, clarification? I feel as if that was the last